Hello all, this is Rajashekara Reddy, Faculty of Department of VIE at VIGNAna JYOTHI. Today I'll be starting a lecture series on control systems. We'll find this term control system everywhere in quite often electrical engineering or mechanical engineering or chemical engineering or biochemical engineering applications. So let me start my lecture by understanding the term system. A formal definition of a system is it is collection of some physical elements, some elements to perform a specific task. So it may be an electrical system or a mechanical system or a chemical system or for that matter a biological system. Our human body is a system that performs a specific task, right? So let me introduce a simple example that we generally use in our daily life. Maybe a water storage tank, so that every house will have a water storage tank. Let me take two things. One is the water storage tank that we have in our home in the top floor, right? And the water storage tank that we generally have for the drinking purpose, right? Maybe each floor of a college will have this storage tank, right? So let me try to introduce this example and try to understand the meaning of system, because I am purposefully saying I'll be talking about control systems. When I say I'll be talking about control system, probably there is something called uncontrolled system, right? So maybe there is a system which is uncontrolled. So first I just wanted to introduce the terms a system, a control system or uncontrolled system, right? So that I will try to explain by using this well-known examples that we generally use in our day-to-day life, right? So let us say the water head tank that we have in our house, right? So probably every morning your mother or your father will be switching on the motor, and that motor will pumps the water to the overhead tank, right? So for an example, let us say in the morning if they forget to switch on the motor, and there will be some outputs, some multiple outputs that that are connected to bathrooms or and other household places, right? So there may be multiple taps, right? So multiple outputs, right? So in every morning your father or mother will be switching on the motor, and that motor will pump the water to the overhead tank, and from that tank you'll be using the water. Let us say, I'm just giving an example, maybe maybe in the morning if your father or mother forgot to switch on the motor, what will happen, right? So there will be no water in the tank, and it will be a discomfort to you. So in the morning I just wanted to go to college at 9 o'clock, so I may have to start at 8 o'clock, and there is no water in the tank, so it will give some sort of discomfort, right? Or else your mother or father switched on the motor, and they forgot to switch off later on. After, let us say, after half an hour, the water has filled completely, the tank is full, and you or your father mother forgot to switch off the motor. So what will happen? The water will overflow. So two things: either it will be a discomfort, or other thing, maybe it will be overflow. Overflow is nothing but waste of electrical energy, right? So this is an example of uncontrolled system. The problem here is that the motor does not know what is happening inside the tank. I mean, the word what is happening inside the tank is the water level inside the tank, right? Is it fully filled, or it is fully drained? So that is the problem. So it doesn't know the happenings of output end. Whereas the same system, slightly with a slight modification, that the system that is placed in the every floor of any college or hospital for that matter, or it may be your washroom flush tank, right? So the same setup with a small modification, it may be something like this. So I have the same tank, but with a small modification, right? Then the modification is that, let me draw it first. So there is a outlet just like your water tank, regular water tank, but and it is the inflow. This is the inflow, and there is an extra fitting, an extra hardware piece that is connected something like this. When you compare these two, this is also tank with an extra fitting, and the extra thing is this: there is a linkage pivoted here, and this is a well-known float. This is a float that is basically used to measure the level, liquid level, right? And here is the tap outlet. And so probably you might have observed this in your regular life also. So whenever you go and try to fill the water from the freezer, that is the water tank that is placed in the floor, probably most of the times it is filled with water, and you might have observed nobody is sitting there and filling the water. Right. So what is the difference between these two things? The difference is that if you really observe that the target is that I need to have water up to this point. Always I need to have water level up to this level, preset level. Right. So that is my requirement. Let us say somebody opened this outlet just to fill the water. What will happen? Let us assume that the tank is now that new water level is maybe somewhere here. Let us say the new let me draw it in a fresh this thing. So let us say somebody has opened just to fill the water. Let us say the new situation, the present situation is this: you have opened the outlet and filled your water. Maybe the water level is here. Now what will happen is that this attachment, the linkage, will move to this position. The float will move to this new position, thereby it will allow the inlet to flow in. This is the inlet, and the automatically it will opens the inlet, will open the inlet, and it will allow the water to flow through the flow into the tank. So that is the difference. So if you really observe the difference here, whenever you open the outlets, outputs or outlets, the input, that is the motor, it doesn't know what is happening at the end, but with a small modification, this setup does know what is happening at the output end. So let us say it is able to detect the change in the liquid level inside the tank, and it is opening accordingly, right? And if you really see this, let me say the length of these linkages, let us say this is L1 and linkage of this two is L2, and let me do some maths. Maybe the initial position is this. Let us say this is the initial situation where the tank is let me point 3 points: A, the pivoted point, and B is the linkage, and C is the float, right? This is the situation where the water is full, and after disturbing the level, maybe this is the situation, new situation, right? So I'm just taking both the situation. So B is moving to here and C is moving to here, and let us say this is my preset height, this is my requirement. So I want my water level to be here always. So let us say this is my preset required height, and this is what the height that the float will measure, right? Let us say let us connect these points, and let us try to understand some maths, right? So, and if you really see, this is the new height, and this is the old reference or preset, my requirement. So I can see a difference between my requirement and the availability. So this is the available water level, and this is what is my requirement. So then in some sense it is the difference between the height, required height, minus the measured height. In some sense this is the difference between the required preset height minus the measured height. So I can treat it as some error, and it is function of time. Of course it is function of time. So this length is representing the difference between the requirement and the availability. Similarly, this position, this length, the difference in these 2 points will indicate the inflow, right? So the amount of the required water inflow just to fill the water, fill the tank up to the required level. So in some sense, this is the input. In some sense, this distance will indicate the input. If I really see these two triangles, they are two perpendicular triangles. One is this triangle. So let me see, and these two lengths are known, L1 and L2. Right. So if I draw them separately, I have two triangles. One is this. This is the right angle, and the length. Probably this angle is common to both the right angle triangles. This length is common to both the triangles, and I can say, if I write the trigonometric angle tan theta here, so the tan theta in a bigger triangle, in the bigger triangle, it would be E of t by L1 plus L2, and in the small triangle, the same tan theta would be maybe U of t by L1, right? So, and I know that they are same, these two are same, so if I can equate them, so E of t by L1 plus L2 is U of t by L1, or in other words, I can write U of t, the input to the system, is L1 by L1 plus L2 times E of t, where E of t is the difference between my requirement and my availability, right? So, and L1 and L2 are known given constant. So in that way, probably I can write U of t is K times, K is L1 by L1 plus L2, a constant, proportionality constant, right? So if I really try to build this system, a open loop, so build both the systems. So let me try to build both the system, the system which is uncontrolled, that is the overhead tank that we use in our house, and the water storage tank that we use to fill water, right? So in first case, the uncontrolled case, where the this case where the input is pumping, the water pumping from the pumped by the motor, this is the input, and the output is water level inside the tank, maybe H of t or Y of t. So in general we call as Y of t. So where the system would be something like this. This is the system, and it is giving some input, maybe electrical input U of t, and I'm getting some output Y of t. In this case it is height, and and the input end doesn't know what is happening at the output end. So that's what we call as uncontrolled or manually controlled system, or it is known as a open loop control system or open loop system in the control literature. Open loop control system or open loop system simply in the control literature. Whereas in the other system, if you really see the construction, so I have a system which has some control over, I mean self-regulation. It is correcting by itself, right? So I have a system, maybe something like this. Similarly, I have some input. It is very similar to that of our the other case, Y of t, maybe H of t in this case, and U of t is the input. If you really see, now this input is this input U of t. In the open loop case, it is manual. In the open loop case, the input that is going to the system is manual. So manual, the meaning is that either you or your father, mother has to switch on and switch off the motor, right? So that's what the manual control. But if you really see the U of t in this case, it is not manual. It is in fact coming from the other element, probably something like this. So it is probably something like this. It is coming from somebody else. So something like this. Let me understand in this way. So this is U of t. The input to the system is not manual. it is already calculated mathematically, and it is coming from somebody else, right? And who is that somebody else? I'll tell you later on, right? So, and this E, I said that this is the error between my requirement, right? So in this case it is H minus H measured. In general it is the difference between my requirement, that in control system that we call this as my requirement as set point or reference, set point or reference, minus measured value, MV or measured value. So let me write it here. So this error is defined in this way, that is reference or set point, that is my requirement. I want to maintain height at certain height, so that is my set point or reference, minus the measured value, right? So maybe I need an element, a mathematical operation that will do this subtraction. So see, this is where my set point or reference, right? And measured is this. I'm measuring the output and giving it back to the system. So probably I need a measurement unit or sensor to do that, right? So we call this as measured value of Y, right? So, and in the control literature, this is referred to as a closed loop system. This is referred to as a closed loop system, where it is it knows what is happening at the output end. So now if you really see, the input is k times E of t, that is nothing but k times set point minus Y measured. That is, the input knows what is happening at the output end. So that is the reason why we call it is intelligent than open loop system. The closed loop systems are generally intelligent than open loop systems, because there is feedback, meaning that it knows, the input knows what is happening at the output end. In that way it avoids the discomfort. The closed loop systems can bring you the comfort, or can reduce the waste of electrical energy. In this example, probably electrical energy, maybe in other examples it may be mechanical energy or chemical energy, right? So the whole idea behind the control, is to probably maybe improve the comfort, maybe luxury, or to reduce the energy spending, right? So now if you really compare these two terms, open loop and closed loop systems, and if you really compare them, you can find some things. See, one thing, maybe this is simple. The open loop system is simple, whereas the closed loop system is a bit complex, right? So I'm just giving the primary comparisons between the open loop and closed loop systems, right? So yes, open loop system is simple because no measurement, no control, right? Right. So, and the closed loop systems are generally complex because of these additional two terms. This is the sensor, and this is generally referred to as a controller, right? Generally this is referred to as a controller, and because of these two terms, closed loop systems are complex than open loop systems, right? But the closed loop systems are expensive. The open loop systems are simple and not so expensive. Whereas the closed loop systems are expensive. And when it comes to the accuracy, it is very clear. So I'm saying that here either the tank will be fully drained out, or the tank will be filled fully. So which means that they are inaccurate, right? So the open loop systems are not so accurate. They are not so accurate. Whereas the closed loop systems are basically, they are accurate. So this is the basic difference, the very basic difference of, there are other differences too, but I need much more things to discuss, just to introduce those terms. They're relatively more like engineering issues. They're the basic comparisons. So that's what in this lecture I have introduced the term control or system, and then control, and the difference between a open loop and closed loop system, and the very basic difference between these two systems, open loop and closed loop systems. Probably in the next coming lectures I'll be talking more on the open loop and closed loop systems and other issues, something very specific to the electrical engineering, or the terms like stability, the robustness, and so on. All right, thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.